Our maps are becoming more and more realistic, but they're also true images of reality, able to model and describe real-world relationships. This is becoming increasingly complex, and we are starting to make more and more carbon copies, digital copies of the world. Digital twins, as we often call them today. GIS and the geographic approach is the framework and process for creating, managing, and applying digital twins. This is improving how we collaborate, but what exactly are digital twins? Various reports have been written about them globally, be it from policy bodies, the AEC industry, or the United Nations more broadly, and about digital twins in the context of GIS locally, such as this Principles for Spatially Enabled Digital Twins from ANZLIC here in Australia and region. These policies and guides or reports describe how this concept starts with physical things, a site location with data feeds. This is where analysis can be done and simulations can be conducted, which leads to insights. And in this way, we can predict the physical world by modeling in the digital world. Fascinating concepts, right? But what does this actually look like? A scene like this typically consists of many, many layers created from different data sources. Let's have a look at a few of them. The schematic buildings and trees in the background are actually from the city of Zurich as part of their open data. This is their interior of the university building. These are simply extruded polygons. Data from the design and construction industry can also be added to the scene, such as this BIM model of the train station. Now you can modify meshes directly in Scene Viewer to make sure the BIM models, be it IFC or Revit, are visible together with the mesh itself. We can also bring in point cloud information to enable us to compare and contrast the proposed design against what the as-built representation of reality looks like, as we can see from the station here. When we add time to the 3D model, it really comes alive. It allows you, for example, to explore the past. We can see how the city has developed over many centuries. We can also show what the city might look like or could look like in the future. Here we are simulating tree growth and analyzing visibility over the next 50 years. So this example from the city of Zurich highlights how ArcGIS can support many different types of data, including public open data or detailed network models, such as for utilities. We also saw how ArcGIS supports analytics to simulate past, present, and projected future scenarios of Zurich's built and natural environments. Data and analytical capabilities empower digital twins to take on many of the business challenges you all face today, making complexity more manageable. But it's not one digital twin. It's many digital twins, which are defined by your business challenges or use cases, not by the underlying data. We understand your challenges and use cases are varied and diverse. Rest assured, resources like this Digital Twin Capabilities Periodic Table, or CPT for short, from the global consortia, Digital Twin Consortia, are invaluable to you and your organization to embark on your own digital twin journey. From descriptive to informative, with real-time connection to sensors and feeds, to predictive, the ability to simulate and forecast, to comprehensive, truly integrating scenario-based modeling, and beyond, with increasing automation as we aspire to achieve the autonomous twin, which there are a few examples of around the globe. We recognize that your own digital twin journey will commence along at some stage or some point of this maturity curve. So let's now take a look at some examples, starting with the comprehensive twin. Singapore's Urban Redevelopment Authority, or URA, have established a comprehensive digital twin to support their urban planning processes. Selecting a study area brings up a panel with past design scenarios, with details such as the year of the study and the status of that proposed scenario. Now, planners can actually leverage this to conduct additional analysis, to refine their plans. For example, wind flow and ventilation are extremely important for a hot and humid climate like Singapore, which we're faced with, it seems like, today in Sydney. Wind simulations can be run and results can be viewed on the web map using 3D voxel layers in ArcGIS. Impressive stuff. Now moving to the next state, the predictive twin, the ability to leverage advanced analytics and simulations in order to predict outcomes. San Francisco International Airport, or SFO for short, have established a predictive twin to simulate the construction of its new terminal extension. SFO's predictive twin enables project managers and other staff members on site to virtually design the new terminal extension and predict any issues with the project schedule and construction sequencing status. Here we have the ability to anticipate, prevent, and predict the future by leveraging the use and reuse of the content from design teams, scheduling, and other resources as part of this marquee project. The next type is what we call the informative twin, integrating IoT sensors on the virtual dynamic model. Port Coast in Vietnam have been using ArcGIS to establish their own informative twin to support planning and operations in some of the largest ports in the world. Port Coast combines reality with real-time, live tracking of shipping vessels alongside their bathymetry data, while highly realistic mesh models enable remote engineering of port facilities alongside the extensive amount of BIM models they have for new infrastructure. We can see their reality mesh on screen now in 2 centimeter resolution using ArcGIS Reality. Whilst the previous digital twins might seem far off on your own journey, starting simply with a descriptive twin is within reach for you and your organization, rest assured. As we introduced at the outset, City of Zurich is home to a wealth of different data, be it open, publicly available, or privately shared models from BIM and CAD as examples. But you can create your own descriptive twin today by using existing 2D vector data you might already be managing and maintaining within Scene Viewer built into ArcGIS Online and ArcGIS Enterprise portal. You can easily drape these 2D vector layers onto your 3D reality mesh, and this provides added value in that it provides both an accurate representation of reality alongside your existing GIS information that is collected, maintained, and used today. So hopefully I've highlighted how location and GIS is the ultimate integrator of digital twins. It is a common canvas of geography bringing together all different types of data across space and time. If you'd like to find out more, please come and have a chat to myself and our colleagues on the kiosk. And we really look forward to seeing your intelligence twins soon in the wild. Thank you.